Hi friends, this is Rakesh from Let's Make Learning Simple channel. Now we are going to discuss about multi-threading in a brief manner using real-time example, and also we are going to discuss about the advantages of multi-threading. So first, what's multi-threading? It's the basic main definition, the general definition of multi-threading is process of executing multiple threads. So you would be in a confusion manner, what's a thread? A thread is a lightweight subprocess. So we'll talk about the thread using the real-time example here. So if you concentrate on this example, then you could easily imagine the definition. You can easily guess the definition without much effort. So this is the real-time example. So every day you would be having dinner. At that time you would be doing multiple tasks at the same time, like eating, watching TV, and then chatting, and then texting. Here, each thing is considered as a separate task or independent task. Here we are doing multiple tasks simultaneously using different methods. For example, to execute this operation eating, we need two things, mouth and hand. To watch TV, we need eyes. To chat, we need mouth. To text, we need hand. Here, each operation or task is executed by something. So that something is called thread. In programming terminologies, each task is executed by a thread. So in programming in case of Java, JVM allocates a thread for each task. So for example, suppose if you are saving a document, that save operation is allocated by the save thread, and grammar check operation is allocated by grammar check thread, like that. So each task is allocated by some threads. So after finishing if a thread's job is completed, means the threads will go to the thread pool. We'll talk more about the thread pool in the upcoming videos. For now, just consider thread pool is a collection of threads. It's like a reservoir. It will give the threads for the whenever the JVM requires, like that. So now you would get a clear idea what is a thread. A thread is a lightweight subprocess. Its basic thing is the tool that is used to execute some task, like that. So now we will come to the advantages of multi-threading. So this is also one of those examples. I have misplaced this here. Actually, it should be placed in this position. So first example is, it doesn't block the user because multi-threads are independent. For example, consider this example. Here we are doing 4 tasks simultaneously. If your parents are saying like that, like me, suppose your parents are saying you shouldn't do any work other than eating, then all these tasks would be freeze. First you need to complete this task, and then you need to choose any of those tasks, like that. Since we are multitask personals, we can do multiple tasks at the same time. So that's the savings time. So in case of programming terminologies and in case of real-time application world, consider we are doing multiple operations like grammar check. If you are writing some document in Google Docs, we are trying to write a big document. So what Google Docs provides us is, it will auto save us. So the first simultaneous operation is auto save, and then grammar check, and then multi-user collaboration. Here 3 tasks are getting executed simultaneously for every few seconds. So this is one of those important multitasking features that is provided by Google Docs. So if suppose there is no multitasking, means then we need to first complete the complete document. First we need to write the complete document, and then we need to manually click the auto save button, and then we need to manually click the grammar check button, and then we need to manually click the multi-user collaboration button. So here it's consume much time. So the Google Docs is helping us to save the time, and then it also saves memory, because technically all the threads shares the same memory. We will talk more about that in the upcoming videos. So thanks for watching this video. At the end of this video, you will see the channel icon here. Please click on that for subscribing the channel. This is Rakesh from Let's Make Learning Simple channel. Now we are going to see the differences between the multitasking methods. So there are two multitasking methods. The first one is multiprocessing and the second one is multithreading. So we'll try to relate these things using some real-time examples so that you can easily get the real content of that. So first, what is a process and what is a thread? Consider these two hands are two processes. This is the first process. This process is meant for doing the factorial operation, and this process is meant to do some prime number operation. So this process has 5 threads. 1, 2, 3, 4, 5 threads. And this process has 5 threads. 1, 2, 3, 4, 5 threads. So actually what I am trying to say is a process is an instance of a program. This is a factorial process and this is an instance of a factorial program. And these threads are subset of a process. Threads are subset of a process. For example, if you are given an operation to do, if you are given an operation to find the factorial of for the following numbers 5, 10, 20, 5 and 4. So your job is to find the factorial of those numbers. So all those numbers, each number will be allocated to each thread. So 5 factorial, 20, 4, 1 and 6 factorial. So this factorial process will try to find those, will try to complete those jobs. So each thread is a subset of a process. And then each process has its own memory, own address in memory. So this one process, this process has its own memory address, this process has its own memory address. But threads share the common memory. Threads share the same memory. And then process is heavyweight. So this is the first process, second process. These two processes heavyweight because every process has its own memory address. So when you are trying to execute some process, it needs to save the memory, it needs to close the register properly. So it's a light heavyweight. Whereas threads are lightweight because threads are subset of a process. They share the same memory. That's why it's lightweight. And then switching from one process to another process requires time. So this is the first process, this is the second process. If you want to switch from this process to this process, means it will take time. The reason for that is the memory needs to be dissipated correctly and then the registers that are used for the process needs to be closed correctly. That's why the time would be higher when compared to threads. So the cost of communication between threads is very low. The reason behind that is we share the same memory, so threads can communicate easily without much time and effort. So the real-time example for those is, for example, if you are opening a single Chrome window and if you are trying to open multiple tabs in that window, means that's multithreading. If you are trying to open multiple windows, means that's multiprocessing. Thanks for watching this video. At the end of this video, you will see the channel icon here. Please click on the first subscribe. Hi friends, this is Rakesh from Let's Make Learning Simple channel. Now we are going to see about the thread lifecycle in a detailed manner. We will try to compare with the real-time scenario for getting these content in a clear manner. So first, there are 5 stages: new, runnable, running, terminator, and non-runnable. So this is the initial stage where the threads are getting created. If you create n number of threads, then n number of threads would be created in this stage only. So all those threads are eligible for running. So all those threads would come here. This is the runnable state. We will try to compare with this real-time scenario. So this running stage, we will compare this running stage. It's a bike. So in your family there are 4 members: you, your brother, your mother, and father. All of them are ready to ride a bike, but at a time only one person can ride a bike. That's the scenario. So your 4 members are here. So each member is a thread. So each thread has some priority. So technically the priority ranges from 1 to 10. 1 is the lowest priority and 10 is the highest priority, and 5 is the normal priority. If suppose your father has the highest priority, if your father has the highest priority 10, then your father would be given opportunity to ride a bike. If suppose your father completes his ride and he moves to the telemeter state. So he don't take the bike for the next few days like that. So then he goes to the telemeter stage. Then still you 3 members eligible for riding a bike. So then next comes the next highest priority thread for the execution. Like that thread goes from the runnable to running state. So now we will see how the state changes from running to non-runnable. If suppose if you are riding a bike, due to some situation you got an accident and you were admitted at the hospital, then you were blocked from using the bike for a few months. So that is called block stage. So block stage. Then you move from running to non-runnable stage. Non-runnable means you are eligible but currently not eligible for execution. This is one scenario. And the second scenario is if you are riding a bike and police stops you at some center and he asks some documents for verification. But you don't have documents at that time. So you were blocked for few minutes and you have to wait for a few minutes for using that resource. So at that time some other members can use those resources. So that's called waiting stage. And then timed waiting. Timed waiting means a particular time. You are telling that I can wait only for few minutes. After that, I will use that resource. So that is called timed waiting. These are the 3 basic scenarios where a thread moves from running to non-runnable state. So, if thread needs to move from non-runnable to runnable, then these scenarios needs to be satisfied. Sleep that. If suppose your thread is sleeping for a few minutes, that is waiting, then that time needs to be done. And resume and then notify. So these are the few triggering cases where the thread moves from non-runnable to non-runnable state. Now we will compare this with the technical information, technical details. So here n number of threads are getting created and all those threads are eligible for running. This running state would be executed by the core. If suppose you are having Intel Core i3 processor, then your processor would have 2 cores, dual core processor. That's a dual core processor. Each core is a hyper-threading capability. So hyper-threading means it can execute 2 threads at a time. So you have 2 dual core processor and hyper-threading 2 threads execution at the same time at that moment. So Intel Core i3 is a dual core processor. Suppose hyper-threading. So 1 core 2 thread execution. So totally 4 threads can be executed simultaneously. So in our scenario, there are n number of threads. So nearly 4 threads can be executed simultaneously, and the other remaining threads are in this thread pool. They are waiting, ready to get executed. These are the steps that makes the thread to move from running to non-runnable. There are many other scenarios where thread moves from running to non-runnable. We'll talk more about those things in the upcoming videos in a detailed manner. For now, just consider these 3 scenarios. Thanks for watching this video. At the end of this video, so you will see the channel icon here. Please click on that for subscribing channel. If you like this video, smash like button. And this is Rakesh from Let's Make Learning Simple channel. Now we are going to see how to create a thread using Java. So Java supports 2 approaches. One, by extending thread class, and the another approach is implementing runnable interface. So the first approach is thread class. As the name itself suggests, the class, any Java class extends object class internally. So this is known to everyone, and this is a new thing. The thread class implements runnable interface. So the abstract methods that are present in the runnable interface needs to be implemented or needs to be overridden in the extended classes. If you are extending this thread class, then you need to override the methods that are present in the runnable interface. We will see how to override those things in the later part of this video. Thread class supports 4 constructors. empty constructor and with the name. This used to create an empty thread. This used to create a thread with some name, and we will talk about these two constructors in the later part of the video. And the second approach is runnable interface. Suppose if you are creating some class, you need to implement this runnable interface for making it eligible for multi-threading. We will see about that in the later part of the video. Runnable interface has only one method, only one abstract method called run. So any class that implements runnable interface needs to override this run method. Then how to start the thread? If suppose you have created a thread object using thread class, example T, then you can simply start the thread by using t.start. That's it. We'll talk about the inner things in the later part of the video. See how to create the threads using extending method and implementing runnable interface. First, we will see the extending thread class. Here, this thread one is some class name that extends thread class. Since it's a extending thread class, the thread class internally implements runnable interface. So this method should override the run method. So I override using some dummy message hello. And then inside the void main, I just created the object for this class thread1, t1. Now this t1 is a thread object. You can directly call t1.start. Till this line creates a new thread, and this line promotes the thread from new state to runnable state. From runnable to running state would be handled by the thread scheduler and JVM. So we shouldn't call t.run. That would be automatically called by the internal JVM and thread executors. So the final output would be hello. If you observe it then you would see the only few minor differences between these two programs. Here we are extending thread class, here we are implementing runnable interface. Thread class internally implements runnable interface. Here we are explicitly implementing runnable interface. So we need to override run method. So we have overridden the run method. Inside the void main, we have created the object for this class. The class that this thread to implement runnable. So for that class we have created the object. Then this object is not a thread object. To make it as a thread object, we need to pass that object in the thread class. This is a thread class object. This is a thread class. And inside these params, inside the constructor params, we need to pass this reference t2. So now this t is the thread object. You can directly call t.start. Then the process would be very similar to this program. So the t.start, this line creates a new thread called t. This line promotes the thread from new state to runnable, and then the JVM and thread executor determines when to make the thread to be a executable state. So that is running state. So the output will be hello. Thanks for watching this video. At the end of this video, you will see the channel icon here. Please click on that for subscribing the channel. If you like this video, please smash the like button, comment it, and so we are going to see about the thread class methods that are frequently used. So these are the thread class methods that are frequently used for various programs across various software industries. So first and foremost thing is run, and then start, and then get priority and set priority, and get name, set name, current thread, get ID, get state, and is alive. We will discuss about those methods in detail using this example. So first we will see what is this class and what is this class. So numeric thread. So this we have created a class called numeric thread that extends the thread class. So basically this numeric thread is also a thread class. in this class we have overridden the run method. So this is the execution part of the thread, and then this execution part prints the values from 1 to 10, and then this alpha thread is similar to this numeric thread. Here the execution part prints the values from A to capital A to capital Z. So this is the basic coding and the basic syntax. We will focus more about those methods using this class. This is thread class methods. In this method, in this class, we have created 2 thread instances. So one is for numeric thread class and another is for alpha thread class. So during this statement execution, numeric thread instance is created and alpha thread instance is created. So both are promoted or both are put in the new state. So we have already discussed in detail about the thread life states in the previous video. If you haven't watched that video, please go and watch that video and then come to this video, so that you could get more details about this thing in a detailed manner. Otherwise you would get more doubts and you would have many confusions. So please go and watch the thread life cycle states and then come to this video. So during this statement, the 2 thread instances are created and they are promoted to the new state. And then we have manually started the thread, numeric thread.start and alpha thread.start. So when we call these methods, the threads that are present in the new state moves to the runnable state. So numeric thread moves from the new state to runnable state, and then alpha thread also moves from the new state to runnable state. And then what we have done is we have printed the state. So we have tried to print the numeric thread state and alpha thread state using this method getState. So what it does is it will try to print the state of the thread instance state. So here it could be runnable, or it could be blocked, or it could be any state based on the execution point. And then what we have done is we have printed the priority of the thread. So numeric thread dot get priority and alpha thread dot get priority. So normally here we haven't set any priority, so the default priority would be printed. So the default and normal priority for a thread is 5. If you have set some priority to the thread, means it will override the normal or default priority and it would print that overridden number. And then what we have done is we are trying to print the thread names using getName method. So this will display the name of the thread, and similarly it will the alpha thread dot getName will display the alpha thread name. So here we haven't set any name, we haven't manually set any name, so it will defaultly give some name. The JVM and thread executed would have given some name for these states, so that would be printed here. So basically the thread name would be thread-0 for this and thread-1 for this, thread-1. And then we have manually set the thread names numeric thread and alpha thread for numeric thread instance and alpha thread instance. This statement would execute those names, numeric thread and alpha thread. And then we are trying to display the current thread name. So thread.current thread.getName. Actually, when we have created these two, during the execution of these two statements, 3 threads would have been created. The first one would be main thread. It would be automatically created by the JVM and the thread executor. The life cycle of that main thread would be from this brace to this closing brace. And then we have manually created 2 threads, numeric thread and alpha threads. So at this statement there would be 3 threads, main thread, numeric thread and alpha thread. At this moment there would be only 1 thread would be executed. So basically if you have a single core and single threader, means only 1 thread could be executed at a particular time. So here we are trying to display the name of the thread that is present, that is executed at the time. So thread dot current thread dot get name, and then we are trying to print the ID of the threads, numeric thread dot get ID and alpha thread dot get ID. It will return the IDs of the following instances, numeric thread and alpha thread. And then we have written the state of the threads. So basically here the state would be runnable or something. Here the state would be terminator like that. It depends on various factors. If suppose the thread completes its execution part, means here we would see the terminator. If suppose the thread is at the running statement, means we would see the running state. And then we are trying to check whether numeric thread is alive. If suppose if it's alive, means it would print numeric thread is alive. If it's not alive, means it would print numeric thread is not alive. Similarly for alpha thread. So first we will try to run this program and we will compare the output with the code. So here 1 to 10. If you have observed closely, you would see the output differently for every execution. Here 1 to 10 is printed, and then A to O, and then some statements are got printed, and then some P to set. If you run the same code for another time, you would see some other output, 1 to 10, A to V, and some statement, and then some other statement. The reason behind that is the thread execution part is not in our control. The thread execution part is in control. The thread execution part is controlled by JVM and thread executor or thread scheduler. So basically 3 threads are present: main thread, numeric thread, and alpha thread. So those 3 threads try to execute simultaneously. Some thread would be present at the runnable state, and some thread would be present at the blocked state, and some thread would be present at the running state. So that's the reason why that execution lines are different for each execution. We will try to compare that output with the code. So here 1 to 10 got printed. So basically after execution of the statement, that numeric thread complete execution was completed, and then it got printed this numeric thread dot state. Here we are trying to print the numeric thread state, numeric thread dot get state. So it would print the state of that numeric thread. So that state is terminated. For alpha thread, the state is runnable, and then we have printed the priority of the threads. So numeric thread dot get priority and alpha thread dot get priority. So basically we haven't assigned any priority manually. So the default priority would be printed 5 and 5. And then we are trying to display the thread names, numeric thread dot get name and alpha thread dot get name. So here the default name would be printed, thread-0 and thread-1. These names were assigned by JVM and thread executors. So suppose if we need to override this name, means we can do that using this statement dot set name. So here we are trying to override that name by numeric thread, and similarly for alpha thread we are trying to override the thread name alpha thread. So here we are trying to print the names, so numeric thread and alpha thread. So default names were overridden, and then we are trying to print the current thread name. So the current thread at that moment, at that point, is main thread, and then we are trying to print the IDs of the threads, the numeric thread dot get ID and alpha thread dot get ID. So these IDs are 9 and 10. These IDs are also assigned by the JVM and thread executor or thread scheduler. And then we are trying to print the thread states of the threads once again. So numeric thread dot get state and alpha thread dot get state. So numeric thread state is already terminated at this point. So here the state would be terminated, whereas alpha thread is still at runnable state. And then we are trying to check whether numeric thread is alive or not. So numeric thread is not alive, whereas alpha thread is alive, and then alpha thread execution part got executed. So alpha thread execution part is to execute the characters from capital A to capital Z. So that got executed. So the output varies for each execution. The reason behind that is all the three threads try to be at various stages, various states. That's the main reason. Thanks for watching. Now we are going to discuss about the sleep method in detail. The first we will discuss what is a sleep method. The sleep method is a method that is present in thread class that is used to sleep a thread for specified amount of time. So for example, if your use case needs that thread needs to sleep for few milliseconds, means you can specify that milliseconds using this sleep inside the sleep method. So for that particular amount of time, the thread would be moved from the thread would be waited in the non-runnable state. After that time, the thread moves from that non-runnable state to runnable state. That is the main usage of sleep. There are two ways that where you can provide the time. The first one is long milliseconds. Here you need to provide the sleep time in milliseconds. The second method is long milliseconds, into nanoseconds. Here you can specify the time both in milliseconds and nanoseconds. So we will dive into the code. This is the simplest program by which we can explain the sleep method in a detailed manner. So I have created three classes, class thread1 and class thread2 and thread sleep. So these two, thread1 class and thread2 class, are very similar. The only differences, there are only two differences between these two classes. That is system.out.println thread1 is going to sleep, system.out.println thread1 woke up. Here system.out.println thread2 is going to sleep, system.out.println thread2 woke up, and everything is similar. So here what we have done is we have extended the thread1 class extends thread. So the properties of thread also comes to the thread1 class. Here we have overridden the run method. Inside that we have used the for loop to print the content to execute the statements for 10 times. The first statement is system.out.println thread1 is going to sleep. So the second statement is we have defined that statement inside try catch block thread.sleep. So what it defines is it is making the thread to sleep for 1000 milliseconds. So at that time the thread moves from the running state to non-runnable state, and then it waits for 1000 milliseconds to make it available for execution. So that's the definition for this statement. And then we have catch the interrupted exception. The reason behind that is that thread.sleep throws an interrupted exception. We need to catch that, otherwise the compile time error would occur. So and then we have printed the another statement called thread1 woke up, and thread2 is very similar to thread1. Now we will see how to use that, what are the key things in this sleep method. Here we have created two instances for thread1 and for thread2 classes, and then we have started both the threads, thread1.start and thread2.start. Here if we run this program, you would see some delay in the output. The reason behind that is we have specified this sleep time as 1000 milliseconds. 1000 milliseconds equal to 1 second. So there is a delay for printing the statements. So I will run it again. See, if you observe it closely, you will see the delay for 1 second. So the output would be very awkward. The reason behind that is the first output is thread1 is going to sleep. So thread1 is going to sleep, and then the second statement that would be executed is thread.sleep 1000 milliseconds. So when JVM executes this statement, what happens is the thread moves from running to non-runnable states. At that time JVM tries to execute any other threads that are available in the runnable state. So while executing this statement, the thread2 instance is available at runnable state. So this code would be executed. The first statement in this code is, in this execution code, is thread2 is going to sleep. That's the reason why we are seeing this two outputs. Thread1 is going to sleep and then thread2 is going to sleep. So after 1000 milliseconds, here now this thread is at a non-runnable state, and this thread is also at non-runnable state for 1000 milliseconds. Since this thread moved to the non-runnable state at first, after 1000 milliseconds it woke up. So after 1000 milliseconds this statement would be executed. Thread 1 woke up. So that's why, okay, we will run it again. The reason behind, see, whenever we are using the thread classes, means you would see the output in awkward way. At sometimes you would see some statements at the first, and at sometimes you would see the same set of statements at the last. The reason behind that is the complete control is under JVM and the thread executor. We don't have the thread executor or thread scheduler. We don't have any control over the statements. Here, the third statement is thread 1 woke up. The reason behind that is this thread got woke up before this thread. That's the reason this statement got executed. So after this statement, this statement would be executed. So thread 1 woke up, and then thread 1 is going to sleep. So after this statement would be executed. So that thread moves from the non-running to non-runnable state. At that time, this state would have been woke up. So this statement would have executed. Thread 2 woke up. So thread 2 woke up, and then this thread moves to the sleeping mode. So this statement would be executed, and then it moves to the sleeping mode. So you would see these kind of outputs in a random manner, because we don't have any control. Just JVM and then thread scheduler have the control over the execution part. So the main thing that we need to know about the sleep is the sleep means it makes it thread to sleep for the specified milliseconds. The main disadvantage of the sleep method is if you have given something like this, means that thread waits for this amount of time. That's very bad in terms of programming way. So that's the main disadvantage of sleep. You need to be very careful while giving the sleep time. Thanks for watching this. Now we are going to discuss about the join method in thread class. This is one of the important methods that is very useful for a software developer in point of software developer angle. Here, join method waits for a thread to die. If a main method calls its join method, then it waits for that current thread to complete its execution. You might be confused a little bit. I will explain in a brief manner using this program. So I have created 3 classes: thread join 1, thread join 2, and thread join 3. All those classes extends thread. So basically these 3 classes are thread class. Inside that we have overridden the run method. All the 3 classes have the same definition except this content. Here T1, here T2, here T3. And then we have created 3 instances for thread join 1, thread join 2, and thread join 3. T1, T2, and T3. Here we have started the thread 1. So T1.start means it promotes the thread from new state to runnable state. And then we have defined another statement, T1.join. What it does is, this statement was called by main thread, and this statement was also called by main thread. Main thread waits for the thread 1 to complete the execution. If suppose here we have execution call, we have execution inside a for loop. Here it tries to print the output T1 0, T1 1, T2 2 up to T1 equal to 9. It waits, the main thread waits until all those lines were printed. After that it tries to execute this statement and then this statement. The reason why we have used join method is the thread execution part is not in our control. It's in the control of thread scheduler. If we want to control that thread execution part, then join method plays a major role. It plays a vital role in that. So if now we will try to run this program, you will see this some awkward output. Here the complete execution of T1 is over. From T1 equal to 0 up to T1 equal to 9. And then T2 gets started. Simultaneously T3 also gets started. Here you see the execution series manner for T1, but for T2 and T3 the execution varies for each execution call. So here T2 execution is in series manner. We will try to run it again. Now also is in execution series manner. We will try to run it again. I think now also it's in a series manner. Now also it's in series manner. Now also it's in series manner. Yes. Now if you observe it closely, T1 statement got completely executed, whereas T2 and T3 got some random output. First T3 0, T3 1, and then T2 0, T2 1, like that. So these lines were controlled by thread scheduler. These were controlled by us by using join method. Thanks. We are going to discuss about the thread group in a detailed manner using real-time examples. So first we will see the definition of the thread group. Java provides a convenient way to group multiple threads in a single object. In such a way, we can suspend, resume, or interrupt group of threads by a single method call. So, for example, if you are working in there's a project called Project X. Under that project, there are two sub-teams called UI team and backend team. So, Project X is the parent, and UI team and backend teams are the children for the Project X. So there are 3 members working in UI team, Sholani, Chenchu and Raja, and there are 4 members working in backend team, Rakesh, Sudha, Sakti and Hemath. Here, if you want to close the Project X because of some reasons like money problem, then the sub teams needs to be closed. So the members who are working under various teams needs to be terminated. So that's the reason why thread group is very useful in real-time examples. So we can relate this with the real-time application. So real-time application, suppose there are n number of threads. N number of threads are doing a particular job. If we need to resume or suspend or interrupt those n number of threads in a single call means we can group those n number of threads using thread group method, thread group option. We will talk more about the thread group in the later part of this video. So we have created a class sample thread that implements runnable interface. So we need to override the run method. Inside the run method, we have just called it thread.sleep for 100 milliseconds. So this method sleeps for 100 milliseconds. So that's the simplest run method. And then we have created the object for sample thread class. Sample thread is an object for that. And then these 3 lines defines how to create a thread group object. So there are 2 ways to create a thread group object. The first way is thread group object name equal to new thread group and the single param. Inside that we need to send the thread group name. So I have sent Project X is the thread group name. And the second option is thread group name, new thread group, 2 params. The first param is the parent thread group. So the parent thread group for UI team is Project X and then the thread group name UI team. Similarly, I have created another thread group called backend team. Inside, I have passed 2 arguments, Project X and backend team as a name. So we have created 3 thread groups: Project X, UI team, backend team. UI team's parent is Project X, backend team's parent is Project X.
And then we have created 8 threads. The first thread, we have sent project X as a thread group, and then project X manager as the name. Similarly, we have created 3 threads, T2, T3, T4. Here we have sent UI team as the parent thread group, and then names as Lenny, Chenchu and Raja. And then we have created 4 threads, T5, T6, T7, T8. Here we have sent backend team as a parent thread group, and Rakesh, Sudha, Sakti, Hemant as thread names. And then we have started 8 threads. Now we are going to see the methods that are present in the thread group. The first and important method is active count. This will return the active threads that are present in that thread group at that moment. So it may vary, depends on the various scenarios. So here project X, the direct thread for project X is T1. But there are 7 threads that are part of UI team group and backend team thread group. UI team and backend team parent is project X. So the project X has one thread as direct one and 7 threads as indirect one. So totally 8 threads. If you run this program, we would see this output. Thread project X thread count 8, thread project X UI team thread count 3, thread project X backend team backend thread count 4. I am trying to comment this line. I will try to explain why I have commented this line in the later part of this video. And then the next important method is active group count. This will return the active groups for the thread group. So for project X, there are 2 active thread groups, UI team and backend team. For UI team, there are no active thread groups, and for backend team, there are no active thread groups. If we run this program, we would see this following output. So project X active thread group count is equal to project X UI team active group count of 0, project X backend active group count is 0. And then there is another important method, get name. This will return the name of the thread group. So project X name is project X, project X UI team name is UI team, project X backend name is backend team. And then important method is get parent dot get name. It will return the parent's name. So you might have a doubt regarding project X parent. We haven't manually assigned any parent for project X, but JVM and Java scheduler default assigns some parent to the thread groups that don't have a parent. So here the project X, we haven't assigned any parent for project X. So JVM and thread scheduler would have assigned some parent. The parent name would be main. So thread group project X parent equal to main, thread group UI team parent is project X, thread group backend parent name is parent project X. So in the I have commented this line. The reason behind that is this destroy method tries to destroy all the threads that are present under project X. So the one thing that we need to make sure is the threads needs to be terminated before calling this method. If we call this method before those threads before the termination, then following exception would occur. Java.lang.illegal thread state exception. So we need to make sure that all the threads that are present under project X needs to be terminated before calling this method. Thanks for watching this video. We are going to discuss about synchronize method. So we will talk more about this method synchronize in a detailed manner using real-time example and also using some program. So first we'll see how to define a method as synchronized one. The simplest way is you need to put the synchronized keyword before the return type. That's it. So if you put the synchronized keyword before the return type, then that method becomes synchronized. So we will try to relate the first statement with the previous explanation. If you declare any method as synchronized, it is known as synchronized method. And then synchronized method is used to lock an object for any shared resource. We can relate an real-time example with this line. For example, if you have a shared resource called bike, your father and your mother have the access to ride a bike. So that bike becomes a shared resource. All the three members have the right to ride at any time. If you have ridden the bike, then other two members don't have the access, because you have the complete control. You have the complete control. You have access the lock of that bike. Only if you releases the bike, or if you releases the bike, then other members can ride it. That's the scenario. That's the exact scenario that relates with the synchronization. Here, for every object there's some lock. If thread accesses lock, then other threads need to wait till that lock become accessible. So that's the thread line. When a thread invokes a synchronized method, it automatically accesses the lock for the object and releases it when the thread completes its task. So we have created a simple class called class sync method table. Inside that we have defined a method called publish synchronized while display table. Here it accepts an integer value, table number, and it will try to print the tables. If you have sent 2 means it will print the 2 table up to 4 times. If you have sent 5 table means it will try to print the 5 tables up to 4 times. That's the simplest method. And then we have created 2 thread classes, sync method thread 1, sync method thread 2, by extending thread class. So here we have sent a object for this class as an argument in the constructor. So using that object, this run method calls a display table method. So sync method thread 1 sends 2 as a value, and sync method thread 2 sends 3 as a value. Now we will see this method synchronization class. So here we have created a shared resource sync method table object. So we have created an object for sync method table called table, and we have sent this object as a shared resource for both the threads, thread 1 and also for the thread 2. So and we have initiated the threads by calling the start method, thread 1 dot start and thread 2 dot start. So we will try to relate an example with synchronization and without synchronization. So now I am trying to remove the synchronized keyboard and I am trying to run the program. Now what it happens is, it will try to print some awkward output. I am going to print table, and then I am going to print table 3 into 1 3, 2 into 1 2, like that. If I run this program again, I will see some awkward output. I am going to print table 2 into 1, I am going to print table 3 into 1. The reason behind that is, here the first thread calls this method table dot display table of 2. So the control goes here. It will try to print, I am going to print table, I am going to print table, and then it will try to print the first value 2 into 1 2. So 2 into 1 into 2, and then the thread 1 goes to sleep mode. So that moves from running state to non-runnable state. At that time, if any other threads are available for execution, means that would be executed. So thread 2 is available for execution, so it will try to print, it will try to access this method. So 3, I am going to print table will be printed here. I am going to print table, and then it will print 3 into 1 3, 3 into 1 3, and then thread 2 goes to sleep mode for 500 milliseconds. At that time thread 1 comes to execution. So when thread 1 comes to execution, thread 2 goes to sleep mode. When thread 2 comes to execution, thread 1 goes to sleep mode. Like that, the process continues up to 4 times. So that's the reason why we are seeing this some awkward output 2 into 1 2 and then 3 into 1 3, 2 into 2 4, 3 into 2 6 like that. So if I put synchronous keyboard and then I run this program, means you will see some sequenced output 2 into 1, 2 into 2 up to 2 into 4 and then 3 into 1 up to 3 into 4. The reason behind that is the first thread would call this method display table of 2. So the control comes here. So the argument value is 2. I am going to print table will be printed here, and then the first value 2 into 1 equal to 2 would be printed. Thread 1 goes to sleep mode for 500 milliseconds. Now thread 2 tries to access this method using the value 3. It will try to access this method, but the log for this method for this object would be present at the thread 1. So the thread 2 waits until it acquires that log. So thread 1 releases the log only when it completes the complete execution. So it will try to execute the complete thing, 2 into 4, 2 into 3, 2 into 4, and then I have finished printing the table. Then thread 1 releases the log. At that time thread 2 accesses that log and it will try to print, I am going to print table 3 into 1, 3 into 2, 3 into 3, 3 into 4, and then I have finished printing the table. So here, if a method is synchronized, mean then the thread that accesses that method needs to have a log. If there is no log for the method, means then that thread needs to wait till it acquires the log. That's the reason we are seeing some sequenced output. So thanks for watching.
Today we are going to discuss about deadlock. So deadlock is a situation that happens at every point of our life. So it happens in programming side, and it also happens in a real-time environment. So for example, we will try to relate this deadlock with a real-time example first, and then we'll try to decode this formal definition. Suppose if you are a engineering student who is studying at the 4th year, so after 4th year you will try to find a job. So whenever you attend an interview, they will ask about your experience. But to get a job, you need experience. Only if you have a job, you will get an experience. So it's a deadlock situation. If you need a job, you need experience. Only if you have a job, you will get an experience. This is one of the deadlock situations that happens in our life. And the second situation is, there are two persons, A and B. A is trying to call B and B is trying to call A at the same time. So what A will hear is, B is on another call, please try after some time. So what B will hear is, A is on another call, please try after some time. So this is one of the deadlock situation. So deadlocks occurs at every point of our life. Similarly, deadlock is also occurring at softwares. So for example, this is a formal definition. Deadlock can occur in a situation when a thread is waiting for an object lock that is acquired by another thread, and second thread is waiting for an object lock that is acquired by first thread. So what it conveys is, there are two threads, thread 1 and thread 2. Thread 1 is depending on thread 2's resource. Thread 2 is depending on thread 1 resource. So both the resources are locked. So thread 1 won't release the lock unless it gets the thread 2 lock. Similarly, thread 2 won't release its resource until it gets the thread 1 resource. Here both the threads depends mutually. So here is the case where deadlock situation occurs. This is the simplest program where we can explain deadlock situation. I have created two threads, thread T1 and thread T2. So inside thread there is a synchronize method, inside run method. So what thread 1 will try to do is, it will try to log the resource 1 before executing the statements that are present under this braces. So it will try to execute this statement, thread 1 logged resource 1. So then it will try to execute this statement thread dot sleep 100 millisecond. So at that time thread 1 will go to the sleep mode for 100 millisecond. So JVM will try to check any other threads are available for execution. So thread 2 is available for execution. It will try to execute this statement. So synchronize resource. So it will try to log the resource 2 before executing the statements that are present under these braces. So it will try to execute thread 2 logged resource 2. So both these statements would be executed. And then thread 2 executes this statement thread dot sleep 100 milliseconds. So thread 2 also move to the sleep mode. So thread 1 is also in sleep mode. So if both the threads got wake up, then thread 1 would be at this position, thread 2 would be at this position. So to execute this statement, thread 1 needs resource 2. To execute this statement, thread 2 needs resource 1. But both the resources are locked. So thread 1 won't execute this statement until it gets the resource 2. Thread 2 won't execute this statement until it gets the resource 1 as a lock. So here is the deadlock situation. Thread 1 depends on thread 2, thread 2 depends on thread 1. So the statements that are present under these braces won't be executed at all. The statements that are present under these braces also won't be executed. So if suppose if you run this program, you would see the following output: thread 1 locked resource 1, thread 2 locked resource 2, and then you would see the JVM is still under running mode, but it won't execute the other two statements. If you want to terminate the program, then you need to manually click on Ctrl C, or you need to click on cross mark and you need to click on S. So this is about the deadlock situation. So thanks for watching.